Okay, good morning. So we are going to start now. Good news, I'm going to see you next week on the class offline. The bad news is we have about 2 or 3 weeks left, so not much to talk on the class. But I hope you prepare your energy and try to be more active on the class. Okay. So today I'm going to give you a quick talk on the new topics, and then I expect to hear your questions in the class session this afternoon and the other day. Okay. All right. So far, what have we discussed? We discussed about function, right? We talk a lot about structure. We talk about how you implement a recursive function, and well, there are tons of things that we have been discussed so far, but those kind of things are still limited in a concept called structure programming. Well, in that programming mechanism, you design your data structure in form of struct, array, and some basic data type. Then you try to write down some routine to implement it, right? And implement some kind of algorithms on those data. And so when you look at structure programming, the core value inside that paradigm is the data, right? The structure. And for that, it has some kind of limitation that you need to overcome in order to make your system more flexible, easier to maintain, and easier to expand, and something else. And that is why after structured programming, people jump into the object-oriented programming. So from this lecture toward the end of the course, we are going to talk about object-oriented programming. Okay, and for the first topics today, we are going to talk some kind of very basic thing related to that. Okay, which is class. So hopefully you can get some concept of the class, what it is and what it does, as well as understand some advantage, and of course hope that you can do write some programming system using object-oriented programming. Now remember that the purpose of this course is not to teach you everything related to object-oriented programming. I'm going to give you everything you need for programming OP. Okay. However, there is the next course called object-oriented programming, and then in that course you are going to learn some other thing, including, um, well, design pattern. Okay. As for me, I believe that design pattern is a very nice thing to learn, but then maybe you cannot apply everything in practice. Just I think 50% of those design pattern can be applied in the industry. However, um, many of them are a little bit heavy and not efficient for implementation in the real world. So, but it's good to know, right? In form of design, then you need to know everything. That's a good thing to learn, right? So I'm not teaching you design pattern here. It's not my job, but you need everything about OP is here. Okay. All right. Let's jump into it. Now, as I discussed from the beginning, there are some disadvantages of structured programming against object-oriented programming. Well, for the structured programming mechanism, you focus more on the process or some action that uh, your program do. Okay, you think about how your program will operate. What is the order of action that you have to perform in your programs, right? And that's the way we have been discussing so far. and somehow it works, but you know, it just does not really interesting when you see that we have a very complicated word, and you cannot think of your program as just a sequence of action. Okay, that is why we have object-oriented programming come into place. Now, it's a mechanism that you have to design your programs not like a sequence of action, but instead you have to change your mindset a little bit, think about object-oriented programming as well a way to program with a ton of objects around you. Okay, how those objects work, how those objects interact to each other. Okay, like a community, right? That's how object-oriented programming works. You think about it as data and action together. Okay, so what is objects? Objects are nothing but instance of some data type. Okay, they are instance of object of some data type that we define. Okay, so think about it. The programming mechanism that we are talking about is nothing new. It's just based on the old concept that we already know, which is the data type defined by user, which is us. Okay, now, I can go on with a lot of limitation of structured programming, but somewhere still find it works in the real world. So let's just skip this part, okay? I don't want to disgrace some other mechanism, but instead we focus on something better, okay? Now, let's talk about the first concept that you need, class, okay? So class, well, it's not the classroom, right? It's just a collections of some object that's sharing the same type, same property, same configuration, and so on. Okay, so in general, class is a user-defined data type. This is important. Okay, we know struct is a user-defined data type, right? So class, okay, so it's class. Now you group together some related information, and those related information are what? Data. Okay, so you have data, but beyond data you get what? Get functions. Okay, now I don't like to use the word functions, but it's like a habit. Sometimes I use that word, sometimes I don't use that word. It's messy, you know. But in general, it is better to use the word method rather than function. Okay, it depends on the documents that you are reading, the books you are reading. They may refer to those words, but I think method is most common words for the function inside the class. Okay. So, well, class are similar structure, but it contain functions. Well, this statement is not so true. In fact, it is wrong for C++. Okay, I will show you on the class later. But for now, what I want to tell you is, well, this statement is not completely right. Just keep in mind that when you define the struct, you focus more on the data. Okay, when you design a class, you now not just focus on the data, but also the behavior that you have. Okay, that's what I mean. And so now we talk about some terminologies that you may encounter during the time working with OP. Okay, the first terminology called objects. Well, this is easy, right? It's an instance of some particular class. So think about class as data type, then you may see some statement like this: integer a. Well, a is the objects of a class of integer. All right. So think about it. In C and C++, some basic data type, including integer, float, and so on, they also be considered as class. Okay. So you can initialize your objects using the initialization method of OP2. This is common. So that's easy, right? There is a mapping you see over there. Now, the second concept that we are talking about is data. Well, data is, well, the words say everything, right? But what I want to say here is it depends a lot on the document you are reading. Some documents refer to data as fields, some use the word members, some use the words attributes, some other use properties. So it varies, depends a lot on what kind of document you are reading. Not depends on me, but well, it's up to you, right? Well, we used fields when we talk about struct more. Okay. For most of case, I believe that we prefer to data as some members of a class, or yeah, attribute or properties is also common, but not so popular as members. So again, it's just the name. You can call it by the alias or whatever. The last terminology we have is function. Well, as I mentioned earlier, we're not going to use the word function, but rather I prefer using method. Well, sometimes I mess up and I use function instead, but keep in mind that it's good to use the word method. Anyway, well, think about a class as like a blueprint of your house. Okay, when you come to some place like Lakeview City or some other house or in the same. I couldn't call it apartment, right? It's like a, s- area of several house which look similar, right? They were built based on the same blueprint, and then the container, the container, and inside there will be a little bit different, depends on house owner anyway. Well, I don't like this kind of example, but somehow it's a good way to imagine what is class and what is object. So you have here a blueprint of your house is like glass. It defines some basic structure, what you have and what kind of properties you have. And each particular house over there is objects. Okay, so they represent the implementation of your class, the real instant of your class. Okay, but they can vary, they can be different, depends on each object. That's the meaning of this. Well, I think I should skip it. It's just very annoying. Anyway, when we talk about OP, you will see there are some very nice feature that OP provide, and those feature, well, I'm not going to talk every feature you are going to use in OP, but rather I will introduce to you some very important feature. Well, here you see three important features, right? The first one is encapsulation. Well, encapsulation means sometimes people say about this feature as a data hiding mechanism. Well, encapsulation means um, you will interact with your objects by the interface rather than some detail. Well, think about it. Long ago, you work with struct. You see everything you have in the struct, right? And you work with struct using functions. And well, everything of the object is exposed. And is that good? I don't think so. Sometimes you would like to protect something inside your data. You want to protect your data, protect something inside your struct, inside your objects, and you don't want it to be modified uh, carelessly by the user. Sometimes users are stupid and they may input something so wrong and it crashes your program. And this is why it is better for you to understand how to protect your data. Okay, so in OP, encapsulation is a concept. Yeah, it is a concept that lets you protect your data from the user. Okay, so you hide the detail of your objects from the user, and you let them operate based on what you allow them to do. Okay, okay. So this is nice because now the user don't need to know the detail of your objects. They only need to know about, okay, what can I do with your objects? Okay, and what they can do with object will be defined through the interface that we are going to talk just a moment later. The second feature that you are going to see here is inheritance. Well, inheritance itself is a very attractive word, right? Um, think about you own a house and then your parent passed down that house to you. You inherit that house, but that's the real world, not in the programming world. Okay, now programming will define inheritance in a different way. It's a way for you to well, reuse whatever already there. Okay, saying about, well, we have human, okay, and then we have man and woman. They inherit something from human, right? Because they are human. Okay, now suppose that human can eat, human can play, human can mate, whatever. Then you can see that the men and women are the children of humans. They inherit some properties of the human. That's kind of imagination is a little bit weird at first, but I think later on you find it clearer. Okay, when you design some class with some example. Well, the third features that I think more important than the other is polymorphism. Polymorphism may be provided by most of OP language because this is very powerful. Well, it's allow you to do something interesting. Okay. Well, what did I write down here? It's allow a value to be one of several types and determining at runtime which function to call based on this type. Well, the statement is a little bit blurry, but well, back to my example before. Think about you have a human, right? A human can eat, a human can play, and human can study, and so on. Now I have some other class like man, women's, and well, some kind of inhumans. I'm not sorry, just men and women, for example. Then well, the way you study may be different. Okay, the way men learn and the way women learn are different. Therefore, the implementation of your man and woman is kind of different. Now, suppose that you have three objects: A, B, C. A is man, B is woman, C is man. Okay, and then they are all human, right? So because all of them are humans, I better manage them in some kind of common array, like human array. And then I say, okay, all human go to class and study. Yes, all of them will study, but depends on the objects. So A will study as man, B will study as woman, and C will study as man. Okay, so that is the idea of polymorphism. Now, we will talk about it later, not now, but just give you the first insight of what it is. Okay. Um, well, here are some more detail about encapsulations. Encapsulation means you pack together the data and some other functions maybe, and those those functions usually called method. We pack them together in class. And then for user, they don't need to know the detail, how your class is implemented, how much detail, how many functions it has. But instead, all you need to know is some method or maybe some data that you want to expose is declared as public. Okay, and those things, if you declare them as public, they are interface. Okay, think about interface as well. You interact with your computer through some interface, right? The keyboard as the input interface, and the screen is output interface. Okay, and so they are public. There's something you can interact. Okay. All right. I think that's enough about encapsulation because I don't want to make it more complicated. It's very simple. Now, if you want to declare a class, what you have to do is you start with a class keyword, okay, and then followed by a class name. Okay, this is mandatory. You cannot ignore the class name because this is important, right? Now you see something different than struct that we discussed before. Okay, there is something called access specifier over here. But just like we mentioned before, user only knows something that you declare as public to the user. So this access specifier define. Sorry, what what is that? This is the way you let the compiler know which member is exposed to the outsider, to the user, which members are hidden from the user. So access specifier, now we have about three types. There is public, which is the word say everything, every user can see it. There is protected. Well, protected means outsider or the user cannot see it. Okay, but still inside your class you can use it. And one more thing, your children depends on the way you inherit. You can see it or not. Okay, you can interact or not, depends on the way you inheritance. You do inheritance. Now the last is private. Well, it's also clear that the user cannot see those member declared as private, but the children cannot see it too. It's still there, but the children cannot see it. Okay, we will talk more detail about it later, but just focus on public right now. It's like something that you let the user see, and we call them the interface. Okay. Here's another example that we think that important. You see, there's a rectangle class, okay, and there we have two member with and height. They are all private, okay, because well, you don't want the user to modify those things, okay. And then you see here there's some public method, and those are the interface. Okay. Well, the interface let the user to interact with your objects. You can either set width, you can either set height, you can get the width, you can get the height, or compute the area of your rectangle. That's easy, right? Um, so if you want the user to interact with your object, you need some method declared as public. Maybe some data you want to public too. Depends on you. Now, let me come to access specifier a little bit. I'm not going to talk much about it, just try to clarify two things, okay? Public is, yeah, I talk about it a lot, right? Private, by default, everything you declare in a class without access specifier will be understood as private, okay? So, uh, as the word say, the outsider cannot see it. No way to access it. Okay, but you can still see and work inside your class. Okay. Now there are some way to define the member functions. Here we go. Um, you can either write it inside your class. For example, here I may, well, let me clear it out a little bit. Let's say I want to get with, okay? And then I may delete this one because I think get with is so simple. So I would write down this one, return with. This one is written inside the class declaration too. And if I do so, I have, well, a method inside a class. Okay. But sometimes the method is a little bit complicated. So it's not good to write down inside your class declaration. It is better to put it somewhere else. In that sense, you may want to write it implementation explicitly in this form. Okay. Uh, like you define, okay, I have a function set width, and this function belong to rectangle class. Okay. It's that simple. Nothing else. You need to implement a functions. Sorry, a method for a class. You just put it outside somewhere in the implementation section, and then put in front the scope operator along with the class name, and that's set. All set. All right. I think this is clear for most of us. We know what happens. Well, there are things that I want to have you clarify again here. That you have to distinguish between declaration and definition. Okay, declaration means you tell the compiler there is a class like that with some member function like that with some data like that, and definition say, okay, I would like to tell you how those method works in my class. Okay, so sometimes I prefer to this as implementation. All right, and well, this is clearer, right? Then when you design a system or the whole programs, then it's a good practice for you to separate your code into two part, a declaration part and definition part. The declaration part is well, the h file that you may be familiar with, like this one. I define a header file that contain only declaration of my class, my struct. Okay, and then I place all the implementation I have in the .cpp file. Okay, it's helped me to manage my code better. Okay, I will show you later. That's easy. Now, when you design a class, you should provide some interface for reading and writing data. So very often in most of case, you may want to provide set and get method. Okay. Well, some may wonder if you let the user set the value for some member inside and let the user read something inside, then why don't you just leave it as public? Well, it's it's simple, right? Think about it. You let the user set some data, but do you believe that the value user set is correct? I don't think so. So you need to perform some kind of checking before you set the data. Now let me go back to with the rectangle, for example. Your rectangle contain two members, right? One is uh, width and one is height. They are double, right? Now, is it make sense if you have a rectangle with a negative width or negative height? I don't think so. So by default, this is better for me to set the width and height to some positive number. Then in the set width and set height, I may set up some check here, like you know what I mean, right? You can use some statement to check the value you set. If it is invalid, then you not set that data. Okay. Now you may some people may argue, no, I want it to be negative also. Fine. If your program behave that way and if the whole system is designed that way, then fine. Okay. There's nothing wrong with it, but sometimes you need to control the set and get method. Get, for example, is another the issues. Uh, it's unlikely that you let the user read your data and then modify your data. So suppose that I have some class, and that class will return you. It has a an array inside, and then you say, I want to get the data. Then you return the pointer to that data for the user through the get method, for example. Uh, if you do so, then yes, the user can access to those member of the array. But then you also let them to modify, and when you let them modify, it means you cannot, you no longer control your objects, or may I say, you break the encapsulation properties of OP. Okay, so it is better for you to keep that in mind. Design set and get depends on your need. Sometimes you should do it. Sometimes you can let it go. Okay. In most of case, I recommend using this one. Well, there is another thing that you may note. Uh, we can define a method as const method. Why is this? Well, it is natural to have a const method in a program where the method uh, does not modify anything inside your objects. Okay, get width, for example, it's only read the data and return it for you. Okay, so it does not modify the width or do anything else. So you may define it as constant method. Okay, same for area. You calculate the area of the rectangle, but then you have no need to modify the width and height of that object. So you may define it as constant. So in this designing step, you see that define a function as constant is not mandatory. you can say so, or you may not say so. It's up to you. It's not that important to me. But in terms of the design, um, then when some developer look at this function, they know that they should not implement some modification instruction inside, and it's have people understand better. Sometimes for the meeting purpose. Sorry, sometimes for the debugging purpose. Anyway, so keep this in mind. Keep that in mind that cons method is not something uh, weird. Okay, it's very natural. Just say I don't want to modify any data. Well, the scope operators we discussed before, right? We talk about you define a function inside the class uh, declaration. That's function called inline functions. And if you define a function outside of the class declaration, it's a normal function. Well, use the word function and method, and sometimes very messy, but they're the same anyway. Okay. Well, I would like to talk a bit about static class member. Now, suppose that you have a class name. Well, let me see. We may have a class named student. Okay, and then you may have student one, student two, and so on. Okay, you may have so many objects of that, and every objects have different kind of properties. So let's say this name is ABC. Okay, and ID is 1A76, whatever. I don't care much. Well, for the second student, you may have DEF. Okay, and 1 8. No, let's see, 1 9. Whatever. Okay, so you see that every object may have different value of properties. Now, if you define some members of your class are static, then they does not belong to the objects. Okay, they no longer belong to the objects. They belong to the class. Therefore, what you see is, let's say I have NS is the number of student, right? And well, if it's a static, then you declare it as this one, static integer. Yes. Okay. Now, think about it. Every objects you have is they have their own data space, their own memory, and your class. Oh, sorry. Your class also have its own memory where all the static members stay in this area. Okay, and think about it now. The NS member can be accessed by SV0, SV1, SV2. Okay, it can also be accessed through the class name student that I will show you later. But again, it's very simple, right? When you declare a member as static, they belong to the class. Okay, they not belong to the object, but belong to the class, and the the data is shared among the objects. Okay, there is only one space, but shared among the objects. Easy, right? What about static functions? Well, the static function means you have a functions that only work with static data. Is that weird? No, because you say this function is static. That also means the functions like static. Let's say void increase. Okay. Now suppose that this function is well a function declared as static, it means it belongs to the class. Okay, and because it belongs to the class, it should not modify any detail inside some objects. Okay, like the name and the ID is something that very private. It belongs to the objects, and this function is static, has no right to modify those things, but it can modify the static member because it's inside the student. Easy to get, right? Whatever static can only work on static. Easy? Okay. I hope it's clear. Now, we talk about very basic concept of constructor and destructor, and trust me, there are something more interesting after this concept that I will see you on the class, and we will have more fun. Well, the constructor is it's a special method, or you may call it function, whatever. It's called automatically when you create an object. Okay, the purpose of the constructor is to set up the initial value for your object. Maybe open the file, maybe open the socket and link to the network and whatever. Okay, so it does a lot of work for initialization. Well, remember that I said earlier that it is not good to declare a variable and then let it alone, right? So it is good for you to declare some variable, but also initialize them. Maybe implicitly or maybe explicitly. So it depends on. Now, constructor come into place. It become a mechanism that lets you to initialize your object easier. Okay. Well, there are some notes about the constructor here that I want you to keep in mind. Um, you cannot return any value in the constructor. No, you don't need to return anything. And because this function is very special, it does not return void either. It has no return type. Okay, and you cannot call that constructor either. You cannot call it. Keep in mind. Okay. Now let's talk about the default constructor. Default constructor is a constructor that takes no arguments. Okay, very easy. So when you declare an object like this, R is an object of rectangle, then in that case, the default constructor will be invoked to do some initialization for your objects. Okay, that's easy. I think I will show you it later in the demonstration on the class, not here. Well, the constructor syntax here, as you can see, uh, very easy, right? It's the same as the normal function, except that it takes a special name, the same name with your class. It return nothing in return. Take no arguments. This is optional, right? If you take no arguments, then this one we call it the default constructor. Okay, and if it takes some arguments, it is no longer called default constructor. So be careful about it. Um, you may have several variables inside your constructor too, and this is fine, absolutely fine. Okay, and suppose that you have a constructor with two arguments here. You want to set up the width and height. So think about it. Width here and height here are two local variable inside the constructor, and then you are going to set it to your member there here, right? Then when you declare your objects, if you want to call that constructor, with two parameters, then you just use this method. Okay, declare the objects and open the bracket and then write down your, just like you call a function. Okay, except that there's no function call here. It's attached to your object when you create the objects. All right. um, you can also have some default parameters. Well, what if you have every default parameters in a constructor? Well, if you set the default value for every single parameters in your constructor, then when you create an object with no arguments like this, by default it will activate your constructor, and it will set up all the default value for your. Okay. uh, I think this is trivial, but still we have to talk about it. It is unlikely that you have a new default constructor. No, it will just activate the code to your exist constructor with some default value. So you have to distinguish between the default constructor and the constructor with parameter list. Okay. Okay. I believe this is clear now. Well, this is nothing new. As you may see, we may have different constructor with different parameter lists. That's absolutely fine. All right. So you can overload constructor easily. Destructor is another special function. The purpose of destructor is the inverse of constructor. The destructor will be invoked when you destroy the objects. Okay, so the sole purpose of destructor is to clean up your objects. Maybe you want to well release all the data, maybe dynamic data that you create during the working during the lifetime of your objects. You may also want to well close the file, flush all the data, or you may also want to well close the internet connection, close the socket whatsoever. Okay, that's the job of the destructor. So because the destructor is the endpoint of your object's life, therefore there's no need to take any arguments, and it is absolutely not called by your program. Okay, is activated by some well, what can I say? When your object is destroyed, that destructor will be activated immediately, but you cannot call it. Okay, just like the constructor, you cannot call this method or function. uh, well, there's some note here. The destructor return no value and does not accept any parameters. All right. And also one more thing, you have one only constructor because it's accept no parameter, so you have just one destructor. That makes sense, right? Well, similar to constructor, destructor has this sign in front of it, and it takes no arguments. This is the mandatory single, the one and only destructor you have in a class. All right. Well, a private member, a private member function is well just a member function, but it will not be called by the user. Well, it is hidden from the user. So, but inside your class, you may call this private member function a lot. So I think that this is quite clear right now. You can also have an array of objects. This is easy, right? You have an array of integer, you have array of float, whatsoever. Then having an array of object is normal, absolutely normal. Like this one, I have an array of rectangles, and then I can also initialize them using the uniform initialization method. Well, is it so weird to you? Well, I don't think so, right? It's like I want to initialize the first objects with two parameters, 2.1 and 3.2. That's it. All right. So that's easy for now. I will demonstrate it later, but keep in mind this is easy. We are far from complicated thing. Um, well, you can also access some data or some members inside your your array using the traditional method. I believe this one is familiar to you, right? And you can also have a pointer to the objects. This is easy. Well, you can either use the traditional method like this one to access some member method or member data if you have the right to, or you may also use this operator to access it using pointer. Either use the traditional way or this way is okay. I'm fine with it. Uh, I personally use the operation here a lot. I often use this one a lot. But sometimes I use this one, not very often. Okay. The first one is more convenient for me, so I prefer that one. Well, the last thing I think we discuss here is the disk pointer. Well, the disk pointer is the pointer to the current objects. Okay, so anytime when you activate any functions, any method inside your class, then when you use this will be the address of the current objects that you are working on. Think about a situation like this one. You set with and for some weird reason, you name your local variable or the same name with your local with your member data. Okay, and by default, of course, you cannot write with equal with because now the local variable will overshadow your local member. Therefore, you may want to use the disk pointer in order to give you the access to that data. Okay, and then you can set the width. Well, I said that it is unlikely that I'm going to use this for the purpose of accessing data. I don't do it quite often, but in some community, they have a rule. They say, okay, if you want to access some member data inside your class, it's better if you use the disk pointer like this one because it is clear. For me, it's annoying because I don't think it is necessary to do so. It's just give you more overhead in skewing. So just use the width and try to avoid using any local variable with the same member name. Okay, and that is better. But in some particular case, this pointer can be very useful. I hope you will find it useful later, but for now, I think that's enough. So again, that's some basic concept of the the class and object-oriented programming. We still have a lot to discuss on the class. So uh, take the note, and then I will see you on the class this afternoon and the other day, and how to get your questions. Okay. I will show you more if you ask more. Okay. All right. If you have any questions, you can type it directly here. I can clarify any concern you have relate to the lecture today. Okay. Um, if you have no questions, then I think we can stop here. Okay. Any questions? Yep. I hear you. So, mm-hmm. Right. Which slide? I think this one. Uh-huh. Yes, it is valid, but uh, well, I will talk with you next week on the class because this topic is related to the copy constructor. Well, the constructor is not simple as I talk with you today because it's kind of complicated when you come into several kind of constructor. There is a copy constructor, there is a move constructor, and there is copy assignment, there's move assignment, and so on. There are tons of concepts that you have to learn, but I think it may be a little bit complicated for some new uh, for some newbie like you guys. Maybe you know it. Okay. But anyway, relate to your questions. You declare rect R1 as 2.6, then you declare another object R2 set to R1. Okay, this is valid as long as you have that constructor, and I will tell you later about it next week. Okay, just keep in mind that this is not something weird. It's just natural, but you need to learn more some extra concept in order to understand it. Well, if you change value of R2, it will not change R1. Okay, because by default, well, if you are using Java, then Java may use the concept of reference. Then when you write down R2 equal R1, it means R2 is a reference to the object R1. That's Java. Maybe some other language use the reference. Then if you modify R2, it's also modify R1. But for this language, R1 is an object and R2 is an object initialized by R1. So R1 and R2 are two different objects. Whatever you do with R2 does not affect R1. Okay, as you see here, R2 is not, mm, well, let me write down here. You have rect R1. You may initialize by something, I don't care. Suppose that you have R2 initialized as R1. Then in your memory, this is R1, okay, and this is R2. They are different, but after the instruction here, the content they are the same, but they are different objects. Then R2 modify can be modified, but does not affect R1. Okay. However, if you say rect reference R2 equal R1, then in this situation you have R1 here and R2 here, but R2 now point to R1. So whatever you do with R2 now will affect R1. Okay, the difference is the reference here. Okay, but in this case you don't have reference, so this is actually just a copy of your R1 objects, a new object. All right, I think this is clear. Any other questions? Okay, I think we are good now. So save your question for the class session we have this afternoon and the other day. I remember Wednesday, no Thursday. I think. Yeah, we have another class on Thursday. So depends on your class. Maybe you join the afternoon class today or the Thursday class. Okay. Uh, write down a lot of your question if you want to, and then I will answer it on the class. Relate to your questions, is this valid or not? Yes, I will answer it next week, because that time we will discuss on the constructor, a lot of constructor. It will be fun on the class. I hope you get it. All right. I think that's enough. So thank you for coming. Okay, I will see you later. Okay, see you guys.